7th or 8th grade, you've known about the pH scale. We know it runs from 0 to 14. If I was a strong acid, where would I be? So like 0, 1, 2. If I was a weak acid, where would I be? So maybe 5, 6-ish. If I was a weak base, 8 or 9. What if I was a strong base? 14. Okay, but why is the strong base at 14? Why? Don't kiss it because it's strong. Because what? It makes a ton of hydroxide, right? If I'm a weak base, why am I at 8 or 9? There's still more hydroxide than hydroniums, but there's not a ton of hydroxide. So it's still, the concentration being lower means it's going to be a lower pH. Why is the strong acid down towards 0? Makes a ton of hydronium. And then weak acids make a fair amount of hydronium, but not a lot. So that's why they're in the middle region. So how does hydronium concentration change from the left to the right on the pH scale? Connor?
Change hydronium?
Mm-hmm.
There's more more concentrated on the left side.
So what happens as you go from left to right? Okay, so concentration of hydronium decreases from left to right. What happens to the concentration of hydroxide, Nick, from left to right across the pH scale? It gets what? So you gotta listen. Hydroxide. So we just answered hydronium decreases from left to right. Right. So hydroxide increases from left to right. So they're combat with each other, right? They're opposites of one another. Yeah.
Whenever something's in brackets, does that mean concentration?
Good point. What does brackets mean? What do brackets mean? Molarity. That means concentration, right? So it's a really shorthand of writing molarity. Or it means the concentration of said thing in brackets. Okay, so what is the relationship? Since we know that as you decrease, as you go from a low pH to a high pH, you decrease the hydronium and you increase the hydroxide. There's a relationship between them. There's a mathematical relationship between them. What is that relationship or that formula that relates those two concentrations? Anybody? Viviana, you got me? So that equals, so you're saying concentration of hydroxide times concentration of hydronium is equal to 1 times 10 to the negative 14th, right? So that relationship should kind of relate to the logarithmic relationship because we know logs are at base 10. So this base 10 here is telling us like what the log is, what the number is, what the pH or POH is. So we don't have to have calculators to do stuff with pH if the numbers are simple enough. So if I have the hydroxide concentration at 1 times 10 to the negative 7th molar, what is the hydronium concentration? How do you do that? Just like that.
Because when you divide,
right. So when you add exponents, when they're at 10 to the exponent, you add the exponents. That equals the total exponent over here. So if this is 1 times 10 to the negative 7, and this is 1 times 10 to the negative 7 plus negative 7 is negative 14. That yields a pH of what? A pH of 7. How are you doing that in your head? Not just because you know when they're equal, it's neutral, but how can you actually do that in your head? The exponent is the pH. Okay, when it's 1, when there's not a number other than 1, when there's numbers other than 1, you can't do that simply. But I will give you easy numbers if I'm giving you no calculator in that case. So the exponent is the pH, only when we're talking about hydronium. Okay, so, and I've made it clear that it's definitely neutral, but the pH can be hydronium's concentration, which is exponent is 7, so the pH is 7. This is telling us the POH. Question?
So for pH and POH, I'm guessing the H and the OH stand for hydronium and hydroxide, right?
Take the words right out of my mouth, yes.
So what does the P stand for?
Potential. Yeah, it's like potential of hydrogen, potential of hydroxide. It's like potential of forming that. Okay, so what if I said the hydronium concentration, so write this down, hydronium concentration is 1 times 10 to the negative 5th. Hydronium concentration is 1 times 10 to the negative 5th. Zach, what's the pH?
pH is 5.
pH is 5. What's the POH? 9. Olivia, what is the hydroxide concentration? 1 times 10 to the negative 9. Nobody even looked at the calculator. So you can do this. That basically, I said pH, or hydronium is 10 to the negative 5th. That's hydronium. Hydroxide completes it, right? So 10 to the negative 5th needs what would complete it? To be a negative 14. A negative 9, right? So that's why hydroxide was what Olivia said to be 1 times 10 to the negative 9. And so I said hydronium is 1 times 10 to the negative 5th. That's why pH was 5, because the 5 and the 5th are related. Does that mean it's acidic, basic, or neutral? It's definitely acidic because the pH is 5. We don't really judge off pH. We judge off pH very, very well. So are we okay with looking at those exponents and knowing that they must equal negative 14?
Is that from like every problem?
Yeah, it is true for every problem, but I'm using very easy numbers, so I'm using 1 times something, or 10 to the something. So it's only when it's 1 in the front are you able to do that math in your head. And I will not give you anything else. I'll give you points. So give me some more pH formulas. We got this one. Thank you, Viviana. Give me another one, Jamie. Without looking at your notes, give me any pH formula. We got that one here. We're good. Give me another one. Now it's hydroxide times hydronium, not plus. Right? These are times. Okay. Of equals pH. Good. Mike, give me another one. Give me one different than these two. So we've had these. I know I did not tell you originally. Actually, I think I don't know to tell you to memorize them. You only need to memorize 3 of them. If you use them enough, they kind of become, embedded in your dreams. Connor, give me another one that's not like these two.
Antilog times negative pH equals hydronium.
Okay, so hydronium concentration is equal to antilog times 10, or antilog of negative pH, or that's equivalent to doing 10 to the negative pH. And I like to show this way to relate what we've been saying this whole time. This exponent is the pH. See? This is exactly the same formula. 1 times 10 to the negative 7th, 10 to the negative pH, that means 7, a pH of 7 for that example I used earlier. So, antilog is the same thing there. So we should know these 3, because every single thing that's H can be equally done for OH. All right, so conjugate acid base pair. Give me an acid ion. Hydrochloric, easy peasy, lemon squeezy. Make it act as an acid. Make it a bad acid. Give me. Yes, that's what it dissociates to, but whenever it acts as an acid, what is it doing? A Bronsted acid. Go for it, teamwork.
Go for it. Alphabet, go. It's the donor.
It's the donor of the H+, right? So if it donates its H+, goes bye-bye, right? What is left?
Well, it's gonna be, I know one of them's gonna be H.
Well, if this is gone, tell me what's left.
Cl.
Cl-, right? Okay, so all I'm doing is just demonstrating the definition of the Bronsted acid or Lowry base. So if this is the acid, what is this called? Conjugate base, right? So I'm showing you the pairing. This is the acid, hydrochloric acid. This is its conjugate base after it's been deprotonated or H pulled off. What's your question?
Well, I know that the H is gonna go into the
Water?
yeah.
To make hydronium, yes. But I'm just doing half the I'm not showing the whole picture. I'm showing half of it because I'm just showing one pair of them. That's it. But let me do another one. What is ammonia?
Ammonia.
Ammonia, not ammonium. NH3. NH3 is ammonia. It's going to usually be a base. What does a base do? Gains the H+. Make it gain an H+. NH4 plus, because it's gaining an H+, so the charge, of course, carries as well. So if this is acting as a base, we call that the base. What do bases make? Conjugate acids. All right, so that's what I mean by pair. Just so we're clear. Anytime you choose an acid, make it deprotonate. Anytime you choose a base, make it protonate. Give it an H+. Okay, what about phenolphthalein? Who knows what color scheme it goes through? Good point.
It's painted as a base, and it says here it's an acid.
Okay, so let me tell us, let's talk about the pH scale as well. Like, when does it turn that color? So phenolphthalein is this long word. It's an indicator. Just like our universal indicator yesterday, that was like 5 different indicators in one, so it had a color change at every single pH. This one is 1. It has 1 color change at a specific pH. Yeah.
Isn't it like pink at like pH of like 8 or 9?
8 or 9, that's perfect. So it's colorless or clear in acid conditions, and whenever you add enough base for it to cross that threshold of pH, I usually say like 8 to 8.5. It could be a little bit more than that. When it goes to basic region, it's going to be like magenta pink, and we'll use this indicator on Tuesday. We'll actually do the lab with this. What is another one you remember from your notes? Cabbage juice. Give me some real ones versus grocery store ones. Methyl orange, methyl red. Give me more. Methyl rainbow. No, give me more. Any more? Can't remember?
Litmus paper.
Litmus paper is another one we will talk about in just a second. So I want you to know a couple more. Here, okay. So bromocresol green is a cool one. It's just cool to say bromocresol green. People are like, what language are you speaking? Thymol blue. So, just take another one under your wing. Adopt it to know. Alizarin yellow. That one's cool. But specifically, I want you to know phenolphthalein and just one other of your choosing. Sometimes I like to ask for one of your choosing for a specific test question. Okay, so thymol. I think actually a lot of people use. Is bromothymol blue here? Yeah, thymol blue is one you may have used in biology. It was greenish, yellowish green in acidic conditions. If you blew into it with your carbon dioxide, your breath makes it turn green. So if you start off blue and turn green. I do like an alien lab. Does anybody have one for biology? Just 2, 3. I have one in my other class. Anyway, all right. So just know another one for me. Litmus paper though is one. Do you guys remember my jingle? My stupid thing I did on the video?
Was there blue, red, acid?
Yeah, it's like if litmus paper. So there's 2 forms of litmus paper: blue and red. Blue and red. And I was like, if it's in the presence of an acid, or I'm sorry, it. What did I say?
Acid turns red.
I was like, I did a dance video.
I heard the clap.
So, blue to red acid. Yeah. Blue turns to red means it's an acid. You have to say it like a valley girl. Blue to red acid. Red to blue means it's in the presence of a base. So, I don't think it's hard to remember. D and D, B and B. I mean, make it work, people. Okay, so know those because that's a very specific one you have to know for the interview course test. Okay, I got a couple more questions that relate to a quiz you're going to take in about 5 minutes.
Did we need to know monoproduct?
Oh yeah, totally skipped that. My bad. So what do mono, di, and tri refer to?
1, 2, 3.
Okay, so 1, 2, and 3. But what is it specifically talking about?
Isn't that like the acid?
So what about the acid though? I heard proton, but you're like the hydrogen, because a hydrogen ion is simply a proton. Look at it. Look on the periodic table. What's on the inside of the nucleus of hydrogen? What's in the nucleus of a hydrogen? A proton. Is there a neutron in there? Why no? It's an atomic mass of 1. It's got 1 proton. If it doesn't weigh more than 1, that means nothing else is in the nucleus. So it's got 1 proton. What's on the outside? An electron, right? Well, when I make an H plus ion, what happened to the electron? It left. So literally the only thing left in the side of the H is just a proton, so we just call it a proton. So give me an example of an acid that's monoprotic, meaning with 1 H in it.
HCl.
HCl, right? Don't get too creative, it's HCl. Give me one that's diprotic. Sulfuric, H, 2SO4. Triprotic, H3PO3 or 4, anything. I'm going 4 for phosphoric acid. Okay, so that's all. It's just the H in the front that's indicating its number, mono, di, or tri. Okay, that's good there. Go ahead and write down the equation for the second bullet point here. Equation, go. Yeah. Phosphoric acid, H3PO4. We're on the second. So this is a review question. You might be thinking hey, what kind of reaction is this? Second bullet point, what of reaction is it? Gia, tell me what you got.
I got Mg plus HCl.
Pause. Maddie, tell me what you got from there.
MgCl.
MgCl. Why is there a 2 there?
Magnesium is a 2.
Right. Magnesium is a 2+ charge. You must crisscross every single time you make an ionic compound. Oh my gosh, we're going to get that tattooed on ourselves. Group tattoo, okay? Ionic compounds must have the crisscross charges. And what else? So we saw the magnesium replace the hydrogen, so they switched spots. So Jack, what else is made? I don't see any oxygen. So if the magnesium just basically traded spots with hydrogen, hydrogen's a lonesome, right? But is it lonesome? H2. No, it has a little like mini-me, H2 gas. Okay, so think about what you would see in that reaction. So Bryson, what would you see happening when magnesium came in contact with hydrochloric acid?
You would see, so you drop magnesium into acid and then probably bubbles.
Bubbles, that's it. You would literally make an observation that bubbles were happening, therefore the evidence of chemical reactions are gas evolution, because this is gas. Oh, you need to balance that. Here we go. All right, cool. So that was an old test question from the exam like 2 years ago. Easy, not bad for your response, yeah. This one is when I could easily ask you on this test. So take 30 seconds and figure out W, X, Y, or Z, which is the acid. Raise your hand when you're ready. Like you just don't care. You do care. You don't have an answer. Alex, what you got? Why? So, this is where we have to consider bitter versus sour. And I asked, the question said which substance is an acid. So, does bitter go with acid or bases? Bases. Because we've all had soap in our mouth. It's bitter, right? Okay, so then look again. Lucas. It should be Z. So, you see your 2 yeses. You're like, yep, it's sour. Yes, it turns litmus paper red, like blue to red acid. And then the other ones kind of disqualify because we have bitter and bitter on X and Y, so they're out. Why is W out?
Because it turns in blue.
Right, and that's blue is base. There you go. Cool. We got Z is the correct answer. This one, no calculator. Read. Keep your hands up if you're ready. Courtney, tell me your logic here.
I said D because for the hydroxide concentration, it's 10 to the -8, and so that means that the other concentration would be 10 to the -6, and that's greater than.
So you're saying there's more hydronium in hydroxide because the exponents are different. More hydronium means that you're on the acidic or basic side. Definitely acidic. Can you tell me the pH of this?
6.
Right, pH is 6. I want you to like go and press your math. You're like, yeah, like logs in my head, lady. Got this. So yeah, if you just take the exponent, it is the pH only when it's multiplied by a coefficient of 1. But the other ones are definitely larger amounts of hydroxide, so they're gonna be on the more basic region. Okay, so let's go ahead and do. We'll do our lab after this. You guys have, go ahead and clear up your desk. You need a periodic table and a piece of paper. No calculators, nothing else. I got everything else I need right now. And after you guys finish 1 through 14, I don't think it'll take you more than 10 minutes. It's a very easy quiz, but I need to still kind of see where we are because I'm adjusting our schedule some to accommodate for Caporelli and a couple of other things coming up, so I'm going to have to do weird testing things. It's great. After you finish this for about 10 minutes, you'll start writing down these BCEs for me, and then we'll do our lab, and I'll explain that shortly. So don't write on these. I need these back. Make sure you pass this back to your colleagues behind you. write on these, write on your notebook paper, and please, if you need to show work for anything, make sure you show work. Is there an extra one to pass out? Is there an extra? So just put your phones in your pocket if you have them in your desk, just in a minute. And I would write any molarity given in scientific notation to help prove the it's going to be on. Okay? So I don't write any of them in scientific notation. I want you to do that. You don't have to show your work. Once you get done with 1 through 14, hold it to the side and pull out a separate sheet of paper for your lab. You can start the pre-lab. All right, please take 1 more minute for me.
Start this.
Take a stab at that last one for me. Circle the front, you're my wonderful organizers. Please go ahead and pass up the multiple choice little sheet, and we'll put that in one pile, and then the notebook paper in another pile. And while you're rattling around papers, get out your crossword that I gave you. Whenever I gave you a crossword. You guys have the crossword. Review crossword. Yeah, put that on your desk for me so I can check it during the lab. The review. Yeah, I didn't know. Sorry, my other class got it earlier. Never mind. Take that back. Do you want in 30 seconds? Pass this over. I didn't scare you. I mean, I did almost say that. If you have it on your desk, put it on your desk today. If you don't have it, I want it tomorrow. Okay? It's a pretty easy crossword.
Which crossword is it?
It's little.
So anyway, pass it up now because we want to review 3 labs together right now. All right, guys, quiz is up in front. Let's go. I just think it's falling. I'm so sorry to stab you. Stabbing you, kidding.
Or don't really use it.
Jordan, those keeps us skipping. All right.
There you go. I put them on your,
All right, I got all the quizzes, right? Yeah. Okay, so I'm gonna get this up tomorrow. My goal is tomorrow. Okay, so 3 lab questions. Let's do this together. Connor Young. Man, let's go for this. Hydrochloric acid reacts with this sodium bicarbonate. Tell me what are the 2 reactants? Spell it out for me though, because I can read. This is your pre-lab, so have this is on a separate piece of paper. This is before we go to our labs. Connor, hydrochloric acid.
HCl.
Okay. Plus.
FH.
We got this first.
Oh, NaHCO3.
Good. Bicarbonate. A beast. You gotta remember it's got the H in it. Jacob, what's it make? And I'm gonna, before you go, I like what you guys are doing with putting your little pluses and minus below that, and now I encourage that. And it really helps you not be a homewrecker because you know the polyatomic is the -1 and it stays together. So do that, if it helps. Go for it.
You want me to say it? You want me to
Spell it.
spell it? H2CO3.
Okay, so this is H getting together with H, CO3, so it makes H2, CO3 because the H's kind of combine like terms, and
Plus
NaCl. Okay, so this one was technically called a neutralization process. I have these go. Sorry. Called a neutralization process because this is an acid for sure. This is a base, and this is baking soda. It doesn't have a hydroxide in it because that's the kind of the deal with all the definitions of bases. Sometimes bases don't have a hydroxide, but most of the time they do. This name is what? Don't say it out loud. Think about it. And who can name this one for me? Go for it, Jacob. Carbonic acid. Where would you find that? Jillian, where would you find carbonic acid? You had it in your hands earlier.
She's like, what? Soda?
Soda. You've acid in your soda. Guys, you're drinking straight up soda. I mean, acid, right? You knew that. But it, of course, breaks down really easily. And what does it make in the soda? Carbon dioxide, right? So that's how we get carbonated. So it's we have carbon dioxide in the form of carbonic acid, and of course sodium chloride. It's balanced. Okay, let's do a hydrolysis. And so I know we reviewed this a little bit already. It's just a double replacement reaction. So the neutralization process is supposed to make a salt in water, and this does actually decompose further. This is something I would teach you. It decomposes further to carbon dioxide and water, so it actually does make water. It just doesn't look like it at first. It's very unstable, so it makes bubbles, which is what we enjoy in our fizzy sodas. All right, so this next one is hydrolysis, and what can you tell me about the difference between these two? Huh? That is electrolysis. This is hydrolysis. So it's the same concept though. Electrolysis uses electricity to break stuff apart. What are we using now to break stuff apart? Water, right? So what are we going to, first off, tell me the formula for this, Connor. This Connor.
Mg.
Uh-huh.
Oh.
Two, right? Because magnesium charges 2. Don't say yields yet. I have to react it with something. Courtney, what do I react it with?
H2O.
Right, and so I'm not going to write it as H2O. How do I like to write it? HOH, because it just helps to see that double replacement part happen. So I encourage you to write it as HOH. So that magnesium is the cation, nitrate's the anion, hydrogen is the cation, hydroxide is the anion. Rushi, what does it make? Mg, OH, 2, because the 2 charge is still with magnesium, and 0.03. Okay, great. So this is one like on your PS 19B where it says like, tell me the pH of the solution at the end after the salt has been mixed with water. Then you're gonna do this in your lab, so make sure you understand this. So this salt is interacting with water, but guess what? It makes an acid and a base, right? Or an acid and a base. The acid and base are competing with each other to control the pH of the ending solution. So tell me, who is this, is this a strong or weak base? How do you know? It's not part of the B, right? Magnesium's above the calcium, it's not part of the B, so we call it a weak base. Go ahead and write WB above that to remember. It's very helpful to write it down so you don't have to keep it in your head. So weak base is there. What about this one? Strong acid. How do you know that? Because you know your 6 strong acids, right? Okay. Who wins the battle? The strong acid. So guess what? This pH is acidic, so the pH is less than 7. Right. That's how you determine the pH of the ending solution after a salt is mixed with water. Yeah.
How do you get the weak base?
Because the couple of strong bases form a B on the periodic table. So I have to turn this on to work. So it's LiNaKRB cesium, and it goes up to calcium. So it's like, magnesium is not part of it, so it's not part of the strong bases. So those, and of course, there are hydroxide versions of that. Okay, so neutralization hydrolysis. We're going to do our hydrolysis lab. It's very easy. You have 4 test tubes. You put 0.2 grams of each of the salts in there, but I'm not making you massive. You're just going to put like a little scoop of it in there. It's about the size of the end of your pinky nail. And you're then going to stir it with a stir rod. And so we're using litmus paper, and the litmus paper gets stuck in the test tube, so don't put the litmus paper in the test tube. Take the stir rod, dip it in the test tube, pull it out, and dot it on the litmus paper so that it will change color. And you know your color changes now. This will take us about maybe 20 minutes. The materials are at the 4 corners of the middle lab stations here. Just don't mix up the scupulas, or make sure you wipe out the scupula well before you insert it into another container. Okay? It's very easy. Hydrolysis lab, go. Make your own groups. You can make groups of 3. Actually, no, same groups as yesterday. Same groups as yesterday because we don't rearrange very well. And you chose yesterday, so that should work for you.
Can I just join whoever?
Yes, you
You need to see what?
So, I said same groups as yesterday, but you need to divide into smaller groups because you guys were in big groups yesterday. So you're at that lab station. It's your lab, nobody else. Lab is your lab.
Get my glasses.
Alright guys, I need to rearrange this a little bit because that's the right uniform cue on this group district. I need to go. You're good. Zach, let me go in your group. Ready? Hey, Nick, will you go to this group down? Okay, I think we're good. I will bring you litmus paper. Just give me about 5 minutes. I will bring you lots and lots of litmus paper. There's not enough for right now. They're asking, it should be at the station. So just whenever you're ready, just go like,
that one was this one. That's ammonium chloride, and that was this one. Sodium acetate. Sodium carbonate. That didn't change color, that one. That one. Okay, one of our things on. Do you want anything? That's the only one. Are you guys done with everything? Okay.
Alright guys, you guys have about 10 minutes left. Make sure you get your results. And hopefully by pouring this solutions down the sink, rinsing out the test tubes in about 5 minutes. guys have a lot of analysis. Make sure you're working on reactions.